Okay, guys, here's your test breakdown. I'm just gonna kind of go over a couple of the test or some problems that have multi-steps to them. If you have a request for an explanation, just shoot me a message either on Remind 101 and or through Canvas. Usually I do get a notification that there's a note or something in my inbox, and I can just pretty much go over a specific question that you might have. If it's something I did not go over in this video, or because like on your key, I didn't work all the problems. So if there's something that you didn't get the same answer to and need clarification, just shoot me an email. A message, and I'll try to just work it out and send you this link to the explanation. So I did highlight the key information on the partial key on things that you need to study. Now, when you get to this page, make sure you know your parts of the circle. I do want to talk about number 9 real quick because there are some prerequisite skills in that problem, meaning that you needed to recall that. Let me make this a little bit larger. Sorry. You needed to recall. Let's click it. That you're seeing that the chords. Ooh, let's see. That you're seeing that the chords are that they are the same here. Sorry about that. So and then they gave you the diameter. This segment right here is your diameter, so we should know that's the right angle. I know this looks bad, but meaning I have a 45, 45, 90 triangle in this instance. So with that being said, you needed to be using that rule, which says that you're going to have x, x, and x root 2. And that's with the long leg. So that's with our diameter here. Our long leg. Our two legs are 3, so that means our diameter is going to be 3 root 2. So they want the exact circumference here. Basically, that means in terms of pi. And whenever I'm working circumference, I can do 2 pi radius, or I can do pi times the diameter. Well, since I already know the diameter is that, 3 root 2, then my circumference is 3 root 2 pi. That's the exact. If I went to the nearest tenth, that's when I have to type that into the calculator. So you do need to kind of remember your 45, 45, 90 relationships along with your 30, 60, 90. The other part, I didn't think these are not really test like. It's just some of the skills are within multi-step within the problem. Now, the one thing we do need to make sure you memorize, because it's not on the formula chart, is how to find the arc length. And I did put that on the partial key, the formula. The length of the arc is part of the circumference. So that part is depending on that central angle. So anytime I need to find the arc length, I take that angle out of 360, the whole circle of 360, and multiply the circumference. Circumference is like what we just said, 2 pi r, or pi times the diameter. So since on this problem, they want you to find the length of LM, this curve right there, well, you had to use the given 140 for this central angle, which means that this piece would have to be 40 because there's a diameter there. So basically, and I did work this out on the partial key, if you needed an explanation, I'm taking that angle out of the 360, then I'm multiplying it by 2 times pi times the radius. And the radius on this problem was 9. Or I could just say the times the diameter, but they gave us the diameter, so I'm just going to plug in that 9. And then, I might just screw up just a little bit. So what I did on the partial key, I just explained that you're going to have to simplify this first. This becomes the fraction 1/9. And then I'm going to simplify this part, which becomes 18 pi. And I'm multiplying them together. I can look at it as like 18 over 1, which just makes top times top. So I have 18 pi over 9, and then back to, I can simplify that. I can go into 18 two times. That's why our answer was 2 pi. Okay, so that's just making sure you follow the steps correctly. You do have some arc link relationships. And then the next thing I want to talk about that is like that you might need to memorize. Let me scroll in real quick. I gave the process or the rule, and that is being able to convert. Let's be able to convert from radians to degrees. So just know that if you're going degrees to radians, you have to multiply by pi over 180. And in this problem here, they gave us the degrees 135. So I take that 135 and I'm going to multiply it by pi over 180. And so, sorry, that's pi. So basically, when I do that, you're going to get 135 over 180 pi. And now all you really need to focus on now, I wonder if I can do that one. The only thing you need to focus now is to simplify this. There you go. And that gets reduced to 3/4. So your answer can be written as 3/4 pi, or you can say, 3 pi over 4. Sorry, that looks bad, but so I did do that one as well. Now, when you get to your equation here, I'll move this around. When you get to your equation, just remember the parts of the equation. Most of y'all did real well on this, on the homeworks that were submitted so far. So just know how to make sure you put it in the form of x minus h parentheses squared plus your y minus k, parentheses squared equals radius squared. So just make sure you're doing that. You know, your center is your h and your k, and your radius, you need to square it when you put it in the formula. So this is the one that's gonna be the way you probably see it on the test, where I've given you the graph, and then from that graph you got to give me the equation or check that the equation was written correctly. I won't have a problem like 23 where you have to use the distance formula. That's just recalling those facts. Now, our next test is definitely 25, which I want to address. I think on the review, the ones I have circled are your test and so the key to this is recognizing you have a tangent, and so because you know segments that appear tangent are tangent, you needed to know that this was a tangent, and you had to use that tangent theorem that states, and I think I did that wrong, that states that a radius is always perpendicular to a tangent. And by doing so, you now are using Pythagorean theorem or your triples, because on here I've already given you that length 5, which means I can just label that radius 5, and now I can focus on this right triangle right here, and I can use Pythagorean theorem, or I can use my triples. So I'm either doing 5 squared plus 12 squared equals c squared, and don't forget your hypotenuse is always opposite the right angle, or this is a 5, 12, exactly 13 triangle. So if it's 13 here on this side, then it's also 13 over here, which they're not asking for the hypotenuse, they're asking for x. So if I want to get my x, just that piece, I'm going to do 13 minus the radius of 5 to get the outside segment, and that's how I came up with the 8. Okay, so you're definitely going to see that, a problem like that. The next one I said you're probably going to see was 27. I needed to make sure that you have to draw a circle. When you're drawing your circle, it doesn't have to be accurate, but basically you need to have in your circle a chord, and then you also need to have in this problem that they tell you here that the distance to that center is 10. So basically, when I draw that little segment right there, we're going to put a 10 there. And since that segment's part of the radius, then you need to know that the chord is getting bisected. And so now you can create a right triangle there. I know that's not very accurate in my drawing, but you can create a right triangle. And in that right triangle, like if I redrew, this leg is 10. And then my other two legs, because the whole chord was 48, would be 24. And you are trying to find, I believe, the radius. Yeah, so we're trying to find this piece here, which is also C. And so we're just doing Pythagorean Theorem to solve that. So that takes care of our chord, tangent theorems, those relationships. Now, I kind of wanted to talk about 28. I can't remember if I circled it or not. I think I might not have. Just making sure you can read your angles or take the given. These are the multi-step that we worked on. I think we had yellow notes with this. So a problem like this is going to require you to label what's given. So they give you the 68 for this arc here. And they also give you 96. I probably should have did that in a different color. But that's from B to E. And then they determine the following. And then they also tell us that we have a diameter. So AC is the diameter. So it's cutting the circle in half. So one of the angles they ask you to find is angle ABC. And with that angle, we should be using the fact that we see an inscribed angle there, which is the semicircle, and because you have a diameter, and so that means that's 90. We should be done with that. Now, then they ask us to look at angle BDE. So maybe tracing the angle and then finding that vertex and then seeing the intercepted arc with that. So now I can see the 96 is corresponding with that angle. And so it's just half that size. So that's going to be 48. And then they also ask us to look at angle CED. So CED is here. Then again, I see the 68 is the intercepted arc with that angle. So again, it's half of that. So we should have 34. And then they want us the measure of the arc, AD. Let me see if I can get that, which is this piece here. And I probably should have did a better job of that. But so I'm using my diameter for that, and since I already have 68, then I'm just going to do 180 from that, and that would have gave us our 112. Okay, so be able to, take what's given, find the missing parts using your intercepted arc or using your inscribed angles. So on this next one, I just want to, on the key, I talked about using, basically, I added a variable, which was a z over here. I don't know if you can see that. Let me fix that. If it lets me, there it is. All right, so yeah, I put a z because I don't have my two arcs to go with x. But if I look here, I have the arc 48, and z is vertical to this angle, and the 82. So I'm going to use that to get to my x. And since it's an interior angle, then the measure of my angle z would be the 48 plus the 82. divided by 2. So if I find that angle, then it will make it a whole lot easier to find my x and then get to my y. So that's basically my little note that I gave you for that. So once you see that, that is, I believe that was 65 when we get that. So then that makes it easy to see that this is 115 because these two are a linear pair. So now for your y, I believe I told you to use your exterior angle because the 58 is the exterior angle and it corresponds with this arc here, okay, and it corresponds with this arc here, which where the y is. So you're doing big arc minus small arc, and then I'm hoping you saw that this is the diameter. So your big arc is the 180 minus the small arc, which is the y. Excuse me. Divided by 2 will equal to the exterior angle, which is 58. Now I know that's horrible. It's probably hard to see. So let me fix that. So then you're just going to work backwards. You're going to just use your algebra skills. Minus y equals 58. So meaning we're going to multiply everything by 2 first. Okay. And so that's going to give us our 180 minus y equals our 116. And then we're solving for y. Okay. So when you get to the next page, there are a couple of test like that I wanted to talk about, mainly which is 33. And so this has some multi-steps in it. So I think I worked it out, but I guess the thing I want to make sure you recognize, I think some people solve the algebra incorrectly. One, we have a radius and tangent, so it's perpendicular. We should be using Pythagorean Theorem. So that means that this is going to be x squared, that's a leg, plus 16 squared, which is also a leg, equals the hypotenuse. And the hypotenuse here is the x plus 8 per squared. Now, I'm going to stress on this part because this is where most of the mistakes are. First of all, this is saying you have two factors of the binomial x plus 8. Okay, so we need to be using our full method first, outer, inner, last, or box method. But you should have 3 terms always after you multiply the two binomials together. Now, on the left side, we'll end up with x squared plus the 256 equals, and then on our right side, if you want to recognize the shortcut, when you have a binomial and you squaring it, you square the first term, which is x squared. You take these first and second term, not combine them, but basically multiply them together. So x times 8 would give you 8x, and then you double it because of that square, so you just double it. So 8x doubled is 16x. And then you look at the last term, which is the 8, and you square that. So that gives you 64. Alright, so now you can see, hopefully, that the x squares are going to end up canceling each other out, and now you're back to a linear equation. So you're just solving for x there. So I just wanted to address that because I know you're definitely going to see something like that where you're going to have to write out the binomial x plus 8, you're going to have to square it and do things like that. So, and then I think, I feel like I did a good job of like showing how to work it out on some of the other problems. 34 is not a test like. 36, I believe, was. Yeah, 36. So on 36, you had to use your exterior angle rule, which means the x angle, which we have is 53, is going to equal the big arc, which is the 65x minus 1, minus the small arc, which is the 29x plus 1, and then you divide it by 2. So when you simplify that, first you're going to multiply everything by 2 to get rid of the division, which makes this 106 equals 65x minus 1 minus 29x plus 1. Now remember, when you're subtracting, that becomes minus 1. Alright, so from there, you're just basic linear equation. You should be good to go. Okay, on this next page, 38 is test-like as well. I don't think I need to talk about that one. It's an interior angle. Our answers were very strong on problems like this on previous homework. But just understand that the 7x plus 8, that's your interior angle, is going to be equal to the 69 plus the 10x minus 5 divided by 2. So it's the average of the arcs. That's why I didn't really want to kind of stress that. But if you need that, just shoot me a message. What I really want to talk about, because these are the complex ones that you will see on your test. So you have to solve them in multiple ways. Now, 40 is not really a test question, but I just kind of wanted to explain it and break it down for you because you have to do some theorem reasoning. So on the diagram, they already marked our arcs for us, and they want to know what is angle P plus angle Q. So when I'm working this out, I want to find what's the relationship of angle P, and angle P, right off the bat, is an exterior angle. It's outside the circle. So that angle P is equal to big arc, and the big arc with angle P goes from B to C. So instead of putting a number there, I'm just going to name them because I don't have all the arc measures here. And then 2, I cannot get to those arc measures because I don't see I have a diameter. So angle P would really be the big arc, which is BC, minus the small arc, which is AD. And then you would take half of that. Or I can say that angle P equals half of the difference of the arc. So we got half of BC minus AD. So that's my angle P. That's the relationship for angle P. Now if I'm looking at my angle Q, which is over here, goes with the arc AD. Angle Q would be half the measure of that arc AD. So the problem here is asking us what is the measure of angle P and Q. Well, to get that, I'm just going to substitute what I know for each one. So I know angle P is, and I'm going to figure out how I'm going to put this on here. So hold on just a second. Angles would be half of BC. And I could see, and I can find that arc because they gave me the 36 and the 80. So I'm doing half of that right there. And that would be our measure of our angle Q. I don't think I gave the final answer. I just said this is how you would get to it. So that takes care of 10, which is definitely test-like. 41, excuse me, I don't think it's on the test. 42 is definitely test-like. Ooh, I think it just messed up on this recording, but sorry about this. So here's basically what we have. We have angle P and angle Q, and I substitute what we had for P, which is the 1/2 BC minus AD. and I substitute the 1/2 AD for Q. So with that being said, I'm just going to distribute and simplify. So really I have 1/2 BC, the arc BC, minus 1/2 the arc AD. But now I'm adding that to 1/2 AD. And then right there I can see these are going to cancel out. They're going to become 0. So I'm left with just 1/2 BC. So the sum of the two, and if I go to the next page, let me zoom in a little bit. Oh, let's talk about this. Yeah, definitely. Let's talk about 44. I'm trying to make room. Sorry. So 44, test like. I think I wrote out all the steps, but this is your tangent. Over here is your secant. So whenever you have a tangent and secant, the rule is you take your tangent, you square it, it's equal to, whole secant times the outside part of the secant. So my tangent in this problem, and the reason why I want to talk about this, because then again you have another binomial that you're squaring. And your whole secant, don't forget to add up your parts. So that's where you get the 5 plus the x times just the outside, which is x. Okay, I know that's horrible. You can't see that. So let me just rewrite that. Excuse me. So when I do my binomial, we talked about that. That's going to be x squared plus 4x plus 4. That's going to equal to, and then I'm going to distribute this x. So that would be 5x plus x squared. And then we see when I subtract the x squares on both sides, they cancel out. And now I'm back to a linear equation, real basic, the 4x plus 4, equals 5x. And now we're just solving for x and then plugging in for KL. So I wanted to address that one because I know that was a test like. So it's 46. Again, we're using the same skills. Don't forget to combine like terms when you do this secant here. When you add the whole parts, this ends up becoming x plus 15. And then the outside part is the x minus 1. So then, again, you have to use your FOIL. So I think I did a good job of giving you the relationship, what property you need to memorize, and what you needed to do to solve the problem. So take the time to look at that. Take time to look at the other color sheets that have those same content on them, and look at old homeworks. You should have all the items in Unit 11 that is posted, or I gave you the table of contents. I need to update it on the Canvas, I think, and I'll send out reminders about that. But make sure you study. This is not a test that you can't not prepare for, because there's a lot of content. So hopefully this helps. And like I said, if you need specific questions, just hit me on Remind11. I should be able to get some time to do some explanations in between helping my mom. All right, thanks.